Hello everyone, welcome back to my channel. Today let's go over a medium level question that I just solved on my own. So I'm super happy about this and I'm very glad that I was able to come up with my own solution to this question without any assistance. So let's go over it and let me show you how I did it. So this is question 3761, minimum absolute distance between mirror pairs. So basically you're given this integer array nums and you want to find a pair of indexes. So notice that I has to be less than j. So that means that j always has to be to the right of I and I to the left of j, where the reverse, so these are integers, we want to reverse them. So this becomes 2, 1. And then we also want to remove any leading zeros if there are leading zeros. So if we have like this, we want to turn this back into this. Basically, if we have 13, for example, that's what we want. So that's what we mean by removing leading zeros. And then we want to see how many pairs are equal. So let's do exactly that. So let's loop from left to right in nums. And let's also do a pointer right in front of I to the end as well, called j. And let's get 1 and 2. So then we can just make this a string. Let's make both of them a string because otherwise you can't reverse an integer. So if reversed of 1, and then we're going to strip away the leading zeros to do this, is going to be equal to 2, then we can count that extra pair. Or we're not counting pairs, but we're counting the minimum distance between the pairs. So let's go ahead and record that distance, which is absolute of the left pointer minus the right pointer, and then return answer at the end. And let's run this. So if answer is the same, infinity, then just return an invalid value of -1, as it says right here, if no mirror pair exists. So run this, submit it. Okay, so Leetcode's been very slow recently. Okay, time limit exceeded. So this is because this is an n-squared solution of nested loops. And so let's think about how we can optimize this. So basically, if you make some observations, notice that there probably is a way to pre-process this data since we're looking for pairs to the right. So why don't we keep track of this current value reversed and left stripped away as an index. And then let's also keep track of the original values as we loop over. So let's go ahead and pre-process 1. So let's say for I, n, and enumerate nums, let's say 1 is still the same, string of n, string, and then reversing it, and then stripping away 0. And let's go ahead and actually record the index, right? So we're pre-processing that. So d of 1 dot append I. So we're just going to say that 1 is here, or we can actually just do this with the original value, because what this allows us to do is pre-process 2 instead, right? Because 2 is to the right, and then let's just go ahead and create 1 on the fly. So this is going to help us basically reduce the time complexity to n, because now we can call 1 the same thing, turn it into a string, reverse the string, and then strip away the leading zeros. And so now, basically, if this 1 is inside of D as a key, then we know that it exists. Then we can print I and D of 1, right? Because that means that somewhere we're trying to find the closest value in here that's bigger than the current index, right? And because we're already processing this from left to right, we can go ahead and run a binary search, right? So this is taking a very long time. I'm not sure what's going on. Okay, so basically you can see that we're going to find the closest index that is bigger. This is not bigger than this value, so we discard it. Otherwise, we take the absolute differences, which is going to be 1 in this case, right? To the right of it. So Then we can go ahead and say bisect right inside of D1, because this is already sorted from left to right in ascending order. That's how we iterate over the array. Inside of I, which bisect right basically finds the very next element that's bigger than it. So then this is very handy. If BL is less than length of D1, then we're in bounds, because if there's not a value that's bigger than the current, then BL, this returns an index, will be out of bounds. So then we can just say if D of 1 of BL is bigger than I, then we have to take the minimum of answer and absolute value of I minus D1 BL, because that's going to be J, right? So then let's actually go ahead and print DI and D1 BL so you can see what I mean. Let's get rid of this. Okay, so you can see here that this is always going to be bigger than this one, and same here. If we do have a result, this value is always going to be bigger than this one because we used bisect right on a sorted list of the indexes that we pre-processed, right? Okay, so let's go ahead and run this. And now this is n log of n instead of n squared. Okay. And then submit it. And there you go, passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any assistance and solve it completely on my own. So that's it for this video, and thank you for watching.